leave this in the dust, because the only reason I wanted to show you this was to get me here. We are not going to do math this way now all of a sudden. To be honest, this math shows up again later. Remember that shirt I wear, e to the I pi plus 1 equals, have I worn that a few times? So e to the I pi is sort of like this rotation. That's sort of the function that keeps track of this rotation. And well, there's a lot more to that story. But basically, later in math, it makes some really ugly math become easy if you just start going, well, let me just rotate it. And then the answer is right there. It's awesome. So it makes later math so much easier. The only reason I want to show you this is because it's true, and it's actually a relatively simple idea. If I multiply by a full -1, that's a full 180 degrees. If I multiply by half of -1, if I multiply by I, that's a 90-degree turn. So of course I times I should be -1, because I want to turn 90 degrees from there. Now, let me show you a different reason why I times I is -1. Yes?
Is I always square root of -1?
Always. It's the definition of it. It's sort of like, is pi always 3.141? Yeah, that's the definition. I like it. So I is the letter that we put in place of square root of -1 just because it looks a little bit better. Yeah. Okay. Here's the other reason. Here's another, again, this other way of looking at things will make a little more immediate sense. But I just wanted to throw this at you just to say that's really is going on in the background. You never have to use this. You never have to think again about this again.
It's like circle.
See?
It's like circle.
Yes. But, so, you keep dragging me back into it, don't you? Real quick. Just, so, I times I is -1. Because it's a 90-degree turn. If I do -1 times I, of course I end up at -I. Doesn't that make sense? Even without this shit, if I said, what's -1 times I? You would go, -I? Yes. So then what's -I times I? Start here and go by 90 degrees. I should end up at 1. And then it starts over. And you just keep going around the circle till you go crazy.
Is it negative times a positive and negative?
We are in the realm of that being difficult to define, because if I is the square root of -1, is I negative? Is I positive? Neither one of those things. It's like half of a negative. Again, this is going further than we have to, but I like the question. Now watch this, watch. A couple different ways. Can somebody remember what square root of 11.7 times square root of 11.7 is? 11.7. Square root of m times square root of m? M. Square root of -1 times square root of -1 is? Alright, so I times I is I squared is -1. You cannot have a problem with that because it's exactly what we know is true. If I call I square root of -1, that means I squared is -1. Has any number done that before today? Any number I squared before it's always been a real number. That's the problem. Every real number, when I square it, comes out positive. We've always been careful to say real. I've always tried to be careful to say real, because now that I have an unreal number, when I square it, it doesn't have to come out positive. In fact, it comes out negative by definition. All right. Oh, I love the look on your faces. You know, like, I came back for this shit? Fireworks are not for this, I'll tell you that. Yes?
So technically this section is about making it okay to be a negative.
It's a more complete picture. We have been disingenuous before this section. And in fact, I think it's time to change the way we teach this entirely. Because we make this seem like, oh yeah, here's this other weird shit that has nothing to do. This is always here. Every time you've ever drawn a real number line, I never had to use this, because did we ever use imaginary numbers before? No. So the imaginary part was always 0. But like here, if I wanted to graph 1 plus I, it would be 1 plus I. It would be right there. 1 plus I. That's the complete picture. But did we ever have this part before? No, this part always had a 0 here. So it was always on the x-axis, on the real axis. So every time you drew a real number line, there was actually an imaginary number line there that you didn't need to draw. It's always been there. In fact, you know what the word lateral means? When you work your lats, that's working out your, anybody work out? Working out your sides, right? So lateral means sides. Cool? So there was somebody who said we should call these lateral numbers because they're the numbers that are to the side of real numbers. Not imaginary numbers, because they're not freaking imaginary. They freaking exist. They're there. So someday maybe we'll change how we teach math, and you're all like, thank God this was the day. Oh, sorry. All right. So again, if you really didn't like this, you don't need it. I just threw it out there to be a different way to look at this. But this is actually complete here for what we need. This logic leads me to this. I can't escape this. This is true. Yes, ma'am?
Is that going to come up in cubes, or is it just, in cubes, or is it just...
Totally. Yes, it will.
Okay.
Because, real quick, I love that question.
Negative.
How many answers should this have? Who remembers? How many answers should this have? Should have 3. How many do we know exist at the moment? What is the cube root of 64?
4.
That's the real cube root. There are 2 other cube roots that are imaginary. So we'll be able to get those now. Yeah. So that rule that if there's a third power, there must be 3 answers, is true. It's just that we don't know about the complex answers until today. Now we'll be able to get the other 2 answers. Oh shit. Yeah, like we'll be able to. Do we want to? Well, you better. You want to. All right. So, here's this one little piece. So, I is I to the first. It's amazing. All right, I to the first is I. What's I squared again? -1. I love it. Because the square root of -1 times the square root of -1 is -1. There's no escaping it. No matter how you feel about it, that's what it must be. And I cubed is I squared times I. But just multiply by 1 more I, right? What's -1 times I? Negative I. Right? -1 times I is -I. Keep going now. What's I to the 4th would be I squared times I squared. What's -1 times -1? 1. And what do you think I to the 0 is? What's anything to the 0? 1. Thank God, it's still true. I like it. All right, let me let that soak in. And again, one reason why I showed you this, and I know I keep going back to this even though I said I wouldn't, it's too bad, is it makes a complete picture now. Here's 1, there's I, here's -1, there's -I. So 1 rotation is I, 2 is -1, 3 is -I, 4 is 1. The 5th rotation, I to the 5th, should be I again, and so forth. So let me see if you guys can see a shortcut here. Yes?
I cube.
Yes?
Lost right there.
Oh, so is it cool? I cubed is I squared times I, right?
Yep.
Cool. I squared is -1. I is I. So -1 times I is -I. I squared, what's I squared?
Okay.
-1. Yeah. And I just love this because it's a beautiful visual that picks up all of these. So now watch. Who knows what I to the 8th is?
1.
1. Because you do 4 and then another 4. Every 4 comes 1 again. Really want this to make sense. So, let me see.
And this one came from 1 squared, I squared times I squared times I squared times I squared.
Or even just I4 times I4.
Which is 1.
1 times 1 is 1, yeah. So every 4th, so where's it going to be 1 again? I to the 12th, I to the 16th. In between, it's going to be one of these values.
So does it always go in order?
Totally. Yeah, as you multiply more and more i's, you keep going in the same order.
So I, -I1. I.
Yeah, exactly. Yeah. So I to the 40th power would be what?
1.
1, because 4 goes into 40 evenly. Stick with me now. Now watch. This is the beauty of this. I know some of you guys have already given up. I can't do anything for you. You just can't give up, because otherwise you'll die in the section and then forever after. This is going to happen forever after today. Answers can include these, because that's the reality. Answers will include complex numbers. I really want this to, obviously I always want it to make sense, but this picture makes it make more sense to me. The fact that I come back to 1 and then just keep going. So here's the whole story. If I have I to the 42nd power, does 4 go into 42? Evenly? No, it's got remainder what?
2.
All right, so then that's the same as I squared,
Which is
-1.
which is -1. That's the shortcut to figure out any power of I. Because it's cyclic, because every fourth one goes back to 1, all you care about is remainder. The remainder tells you where you are. If I have a 0 remainder, I'm at 1. If I have a remainder of 1, I'm at I. If I have a remainder of 2, I'm at -1. Because of the cyclic nature. Cyclic. Right, so there's a lot of things in math that are cyclic. The more I say that, the worse it sounds. So what about I to the 78th power?
Goes to 3. So, -1.
I always go, what's the next number around 78 that 4 goes into? 80. So it also goes into 76 because that's 4 below. So what would the remainder be? 2. I like it. So be I squared, -1. And then, whatever I give you, you just divide it by 4, see what the remainder is. That's all you got to do. Because of the fact that it's cyclic like this. All right. Now, the most important thing beyond just the definition of I, this is the most important thing. The second most important thing is this fact. So let's build our way up to why that's true. Okay.
So 78 we can divide by 3 too.
Say again?
78.
But that doesn't matter because the cycle isn't based on 3. The cycle is based on 4. That's why we always have to use 4. Every fourth one comes back to 1. So if it was I-80, that's a full 24, so that would be 1. Comes back to 1. So I got to do it by 4. Yes, sir.
So, I squared is equal to -1, even though I is equal to negative. Oh no, I is equal to square root.
Square root of -1. That's the key. So I see this sneaking in all the time. I see this, but this is not true. If I was -1, why the hell would we have made I up in the first place? We already have -1. Right? It must take the place of something freaky, which is the square root of -1. Which then makes this just like obvious.
Yeah.
No matter how you feel about the existence of this, and it doesn't care if you don't believe in it, it exists. Right? Then that means that I squared must be -1. That's all there is to it. So we'll have just look at it, math people just playing with shit, playing with numbers. We do sometimes. Is that? No, that must be true if we can say that. That's all there is to it. So here's how this works. So I keep saying the word complex number. A complex number has a real part and an imaginary part. And I already wrote a complex number up here. Can you write, Jeff? So it would be like I had the number 1 plus I. That's a complex number. Every number we've seen before today has also been a complex number. It's just the coefficient of I was 0. So every complex number looks like this. So every real number has B equal to...
I.
Give me a real number.
1.
2 is a real number. 2 plus how many i's are there in 2? 0. So every real number just has B equal to 0. That relates to me saying I didn't need the imaginary axis because they only needed one axis. 2 axes. Every real number before only needs one axis. But the other axis has just been sitting there like, I'm ready whenever you need me. I'm here. All right, maybe. So every complex number looks like this. So what... I really want this to make sense. There's a real part... And so every number you've seen before today, B was 0. That's all. It's like a slope of 0. It's just, on the y-axis. All right? Okay. Sorry, x-axis. So what's your gut tell you? Yes, I just said this. With all this weird shit, happening, what does your gut tell you this should be?
Seven plus
Careful.
5.
maybe 2i.
7 minus 2i.
That's a 3.
What's happening with the 7?
8, 5. No, 8.
So what's this? This is plus here, right?
Yeah.
What's that?
8 minus 2x.
8 minus 2x. Okay, that should take no time at all to answer that question. It's the same damn question, isn't it? I want you to realize when I'm adding stuff, I just collect my real parts and my imaginary parts because they're like terms. So I get 8
minus 2i.
done. Right? So when I'm adding complex numbers or subtracting them, it's beautiful. It's just like x. Because what is I? Something I don't know, something freaky. So then I just want to add up how many I've got of those. And then in the non-freaky stuff. So the non-freaky stuff, I got 8 of those. Freaky stuff, I got minus 2 of those. Just combining like terms. Are you guys, let that be easy. That's nothing new. So instead of x, I'm using I. Why isn't I exactly like x, though? Because we know the value of I. The square root of negative 1. So it doesn't act like x everywhere. So for example, what do you guys think about... Well, no, let me not ask that question. You might answer honestly. Now I want you to multiply these. So your first step is old news. I want to see who picks up on what the new news is. So the first couple steps, old news. What do you get?
Minus 10x plus 6.
Minus 8 I squared.
I love it. So then, just got one color today. So I get 15
Minus
14.
But what can I do with this? This is what I meant by the I squared part is the most important thing to know. It's the one that opens the opens.
Yeah.
So that turns
Opens the
A
max.
to positive 8?
Say again? Sorry?
I squared is negative 1.
Yeah, so you get 15 minus 14i minus 8 times negative 1.
Which is positive.
But see, on this problem, for some reason, people replace I with negative 1. You know that I is not negative 1. That wouldn't make any sense. And you're all like, it makes just as much sense as the rest of this shit. But just, come on. I is square root of negative 1, which means I squared is negative 1. So the first couple steps felt like old news. The only new thing is I is not really a variable. I know what it is. In I squared, I can replace it with a nice real number. So then I get 15 minus 14i plus 8. So I get
23 minus 14i.
cool. I like it. So even that's not evil as long as you remember, as you must, that I squared equals negative 1. So I don't know if you realize, every day before today, when I said you can't multiply a real number by itself to get a negative, I made sure that I said real number, because it's not true in general. I can multiply an imaginary number by itself and get negative 1 all day long. All right, so what about, remind me, at first this might seem like it has nothing to do with what we're doing. How would you do this? After you cry, wipe it away. There's no crying. There's no crying in that.
Use the... What's it called? The opposite of the denominator? Conjugate. Right?
Yes, conjugate. Right? You guys remember that? You multiply by the square root of 5 plus 2 rad 7. Blah, blah, blah. If you like that problem, you can do it. Screw that problem. I just want you to remember that's what you do. What is I? What is I?
Square root of negative 1.
Square root of negative 1. So I is a radical. So if I had this, what would you do? Same thing you just did. Multiply by 5 plus 3i, top and bottom. Remarkably enough, we call that the complex conjugate, because it's the conjugate of a complex number. It's amazing how creative we are. Yes?
So is that 3 rad negative 1? Same thing?
I have the one color. Sorry. Where, Matt? Sorry?
Is that minus 3 rad negative 1?
Exactly. That's what it is in the background. So now I can multiply this by 5 plus 3i. Bless you. Bless you. Over 5. There's the money. 3 in a row is money. It's the exact same reasoning as what we do here. Exactly the same reasoning. And so on the top, what do we get?
31.
Bless you.
21 10 6i squared.
Yes. 25. Minus 15i plus 15i. We created it so the middle term would cancel, right? Then you get
Plus 9i squared.
minus
I'm sorry. Minus
9 squared. So this becomes, what's I squared?
negative 1.
Negative 1. So this
That's
becomes
negative 6.
minus 6. 35 minus 6 is 29. And I can put the middle terms together.
12. Right. Oh, it is 21. Okay.
And the same thing happens down here, right? I squared is
Negative 1.
negative 1. So this is 25 minus 9, negative 1. 25 plus 9.
So 34.
34. And couldn't I if I wanted to? If you stop right there, I'm not going to take any points off. But what does every complex number look like? What does every complex number look like?
29.
No, that's too specific. What does every complex number look like?
X plus B. I plus
Yeah.
BI.
A plus bi. I like it. So a complex number divided by a complex number should be a complex number. 29 over 34 is A. 31 over 34 is B. If you don't go here, you're fine. You can leave it like this. This is technically the right answer, but this is in the form of a complex number. A plus bi. I can see the real part. I can see the imaginary part. You know you're wrong if you can't put it in that form.
Is the I at the bottom or is it on the side?
It's on the side. My bad.
Oh.
I don't know if you're really. I on the bottom kind of sucks, but you can deal with it the same way we just did. Multiply by itself, really, to be honest. So what did I mean by what I just said? What's 1 divided by I? Well, you can multiply by.
Negative.
Yeah, negative I, just I, really. If there's just one term, multiply by itself. So I get I over I squared. What's I squared? Negative I. So 1 divided by I is negative I. Sure, Jeff. But see, this is what parts of math are like. You make a definition. You figure out what that definition implies. Well, that implies I squared is negative 1. Holy shit, that's weird. That's weird. All right, let's keep playing with it. What does it mean about I cubed and so forth? And then you start doing this kind of stuff. What's that mean about this? How would I do this? It's a radical, so I'm going to treat it just like it's a radical. That's how I would do that, right? So it sucks. Complex numbers suck in the first place because they're weird and freaky and new. But they really suck when they're on the bottom. So you see the problem we just did? Didn't it start off totally complex on the bottom? What's it at the end? It becomes 34. Oh, nice 34. 34 is a good number, right? It's a nice age. I remember 34. All right. All right. So let me see. You guys, let me have you try a couple problems out. I can make some up. Do these 2 problems real quick. Real fast. catch up to you guys. So here I get at plus 4i, 2i,
Minus 7i squared.
I like it. So we get 8
Plus 10i.
plus 10i.
Minus 7.
Plus
times
7.
negative 1.
Yeah, minus 7 to the negative 1, I like it, which becomes plus 7. 8 plus 7. Cool. A plus bi. I can see the real part and the imaginary part. So this one, how do I divide these? What do I have to actually do?
Multiply by.
Good, multiply by the
Conjugate.
conjugate.
2 plus 5.
So it's not quite the same as this. I get some of the same numbers, but it's plus here, right? So
Yeah, it's
it'll be
positive 4 is the difference.
Plus 4.
And it's
what's happening?
plus 7i squared. Those are the difference.
Oh, okay, okay. So you get 8 plus 4i plus 14i plus 7i squared. On the bottom, it should be easier.
4 minus 8.
It gotta be 4
minus 8.
minus I squared, because the middle terms cancel. We forced it to have that happen. Don't always skip the middle terms, only when you know they're going to go away. So whenever I see an I squared, I can replace it with,
Minus 7.
yeah, this will be 8 plus 18i plus 7 times negative 1 over 4 minus negative 1. So 8 minus 7,
1.
1 plus 18i over 4 plus 1.
5.
5, which you can write as 1/5 plus 18/5 I if you want to. So you can see A and you can see B.
If you want to go further, so 1
Yeah,
over 5.
yeah, yeah. I might as well write it instead of just say 1/5 plus 18/5 I. So you can see A, you can see B.
Oh,
I like it. I like it. I'm in the minority, but I don't care. It's awesome. It's not that bad. It's very similar to what we've done before, but the very fundamental idea of it's like, what the shit? So I understand that, but actually using it computationally, not that difficult. But it is a big step to take conceptually to allow for this to exist, right, in our brains. There's a lot of misconceptions about this. Yes, ma'am.
So, is there two answers? Because you circle that one, the 15 plus 10i. Is that the complex answer?
This is problem number 1,
Problem number one?
and that's problem number 2. So here I was multiplying these, and here I was dividing these.
Yeah.
Yeah. So 15 plus 10i is the answer to multiplying them. That ugly thing is the answer to dividing them.
Oh, so this.
Yeah. Makes sense. Division normally ends up with uglier answers. Yes.
So it's 1/5 plus 15.
1/5 plus 18/5 I. Yeah. That's
Or
the
1 over 18i over 5. Which is
Yeah.
better?
Either way is fine with me. Yeah. Just some teachers are, just to warn you, in case you have to take 176, and you have a teacher that must be written as A plus BI. Just realize you can go one extra step there. Yeah. They just need to really take the stick out of there.